In this video, we are going to learn that integration is just calculating the area under the curve. So what do I mean by that? So if you have a function, so this, let's call it f of x. This is along the x-axis. If you want to find out how much this area is, that's equivalent to carrying out the integral of this function over the period. Let's say this is from b and this is from a, so a to b. And to show this, we are going to calculate the area of a circle. And number two, slightly tougher problem, the area of an ellipse. Let's firstly, a circle. Now a circle starts here, roughly, say it has radius r. The equation that defines the circle, x, y, it's x squared plus y squared, r squared. And we are going to calculate the area by calculating the area of 1/4 of the circle and multiplying that by 4 times. First, let's find out what the function is that we have to integrate. So y squared here will be equal to r squared minus x squared, and that tells you that y equals to r squared minus x squared. And we can have both positive and negative solutions, and we shall only work with the positive root. All right. So now we have our function f of x is root over of r squared minus x squared, and we want to integrate from, if you remember this, how the circle sector was, this goes from x equals to 0 here to x equals to r, so x 0 r squared minus x squared dx. Now to solve this integral, we will use something called a method of substitution, where we say that x is equal to r cosine theta. Then dx will be equal to minus r sine theta d theta. And if we calculate the limits for x equals to 0 equals to r cosine theta, this means that theta equals to pi over 2, and x equals to r cosine theta. This means theta equals to 0. Taking all of these things into account, we have an integral from pi over 2 to 0. Now r squared minus x squared is r squared minus r squared cosine squared theta, and then dx is minus r sine theta d theta. Now this thing is the same as 0 to pi over 2 r squared root over of 1 minus cosine squared theta into sine theta d theta. Now I've taken the negative sign that appears here and basically flipped the order of the limits, which is essentially doing the same thing. Now we know that sine squared theta plus cosine squared theta equals 1, and therefore 1 minus cosine squared theta is sine squared theta. And so we can write this as r squared from 0 to pi over 2 sine squared theta theta. All right, let's take a page. So we are stuck with area is equal to r squared 0 pi over 2 r sorry, sine square theta d theta, that's equal to r square 0 to pi over 2. Let's divide by 2 and put a 2 here. Now there is a trigonometric identity which tells you that cosine theta is equal to 1 minus 2 sine square theta. And this would imply that sine square theta is 1 minus cosine theta. So here we then have r squared 2, 0 to pi over 2, and then 1 minus cosine 2 theta d theta. So the first term here simply gives you pi over 2. And second term gives you, so integral of cosine 2 theta is half sine 2 theta, and this has to be calculated from 0 to pi over 2. Now you see that both for 0 and for pi over 2, this value is exactly 0, and so you end up getting pi r squared over 4. Now remember, we had to, for the area of the full circle, what we needed to do was 4 times this area, and that comes to 4 times pi r squared 4, and that is pi r squared, the formula that we are all very familiar with. Okay. Now let's talk about the ellipse. In many ways, almost identical to a circle, and you can think of it as a squashed circle. So let's draw one out. What I mean is like a circle with this length is a and this length is b, and the equation for the curve is just as we did before. We are going to calculate first the area of this segment, and then we're going to multiply that by 4 times. So the area of that segment, again, the same way as we did for the circle, we first need to calculate the function that we need to, the area for that. So the function f of x here would be b times 1 minus x squared over a squared, and this is equal to b over a squared minus x squared. So when we are integrating the area is from x equals to 0 to x equals to a, b over a integral of a squared minus x squared dx. And this is going to be again equal to 0 to a, b over a over square minus square dx. Now this integral we already calculated in the previous example of the circle, and that should just be equal to b over a. Remember that this thing for the circle was a equal to r, a equal to r, and that was pi a square over 4. And so this thing then comes out to be pi b a over 4, and therefore the full area of the ellipse is pi b. And so that is pretty much how calculate areas under the curves.